Currently looking after the concrete reuse strategy for the site. That's all concrete generated on site within the waste management department. The aim of my presentation today is to give an overview of what we're doing with concrete at Bradwell, what Bradwell is doing as a whole, because we're a very busy site at the moment, busiest in fleet for Magnox, and look at the problems, challenges and benefits we've seen from concrete reuse on site. So this is Bradwell, for those of you who don't know it. We are on the Blackwater Estuary in Essex, so quite handily in the southeast. Bradwell is a twin unit Magnox reactor with shared ancillary services and a shared turbine hall. This photo is from 2012, so the majority of the turbine hall is actually gone. The site was constructed between 1956 and 1962 and successfully generated power until 2002. Over 60 terawatt hours in its lifetime. Defuelling completed in 2006, and in 2011, Bradwell, along with Trosfinid, were nominated for accelerated decommissioning. In reality, this means we're doing 7 years of care and maintenance preparations in just 4 years. I'll get onto the main programmes in a minute, but this is Bradwell in construction in 1958. You can see the boilers going up there, R1 and R2. This is Bradwell during operations, and the key thing to take from this photo is our turbine hall here and our cooling water pump house voids here. The turbine hall is now completely gone, and I'll show a photo of that in a minute. This is us as we were looking 2015, once we'd completed care and maintenance preparations. Both reactors will have been reclad and put into a safe store condition. The turbine hall void is present still, but all other ancillary structures and voids have been capped and closed. And we have an ILW store, a new build, towards the south of the site. So, accelerated decommissioning, what does it mean and what does it do for concrete reuse? 17 years work in 4 years. That's a lot of acceleration, that's a lot of work intensification. We're now doing programmes side by side, which should have run simultaneously. So we're doing general conventional decommissioning and demolition works at the same as ILW treatment works. There are 4 main programmes, of which only 2 are important to concrete reuse. We've got the ILW programmes, who are charged with, among other things, constructing a new ILW store on site. They actually generate and require quite a lot of concrete for this construction project. And then we've got the plant structures programme. They carry out most of the enabling works for our project, and they also undertake most of the demolition works. So all the ancillary structures that are going to disappear in the next 2 or 3 years will be taken out by the plant and structures team, and the entire recladding both reactors will be undertaken by the plant and structures team. All of this work generates a significant amount of concrete. So we have a concrete strategy. Hazardous concrete, as you know, anybody who knows a Magnox reactor, we have a lot of oil in Magnox reactors, particularly circulator halls. All of our hazardous concrete goes off site for treatment and recycling as a waste. For non-hazardous concrete, we can either reuse on site under a clear code of practice, or we can send for recycling off site under a waste exemption. Inert concrete, we try and maintain as much inert concrete as we possibly can on site for reuse, either as a material under a clear code of practice or as a waste under a RAP quality protocol. Procedures are in place to identify, before project start construction, any material that may be suitable for reuse on site. This allows us to segregate at source and prevent the potential for cross-contamination. So, the RAP quality protocol. Bradwell's been using the RAP quality protocol for about 5 years in concrete reuse, and we've had a high level of success, backfilling part of our cooling water pump house voids, which I'll come to in a minute, and partially filling the turbine hall basement. We're now moving away from the RAP quality protocol. Like the Salford example, we have high chlorides in our concrete, which precludes us using the RAP quality protocol from a lot of our material. So we are switching over to a clear code of practice. We currently have 2 in operation. We've got a generic site requirement to backfill the large voids left by building demolition. And we also have project-specific requirements. Specifically, when we're going to build our ILW store, we have a requirement to build piling mats and haulage roads. So to give a comparison, the Inert WACA criteria are what you can accept under the RAP quality protocol, and our site-specific thresholds for reuse under the Clear Code of Practice are generally an order of magnitude higher. This means we can accept significantly more of site-generated material for reuse on site. So, to use a Clear Code of Practice, we need to demonstrate 4 key things. The first being that we don't contravene the Revised Waste Framework Directive, that the material is suitable for reuse, that we only use the quantity required, and that we have a certainty of reuse. To ensure that we don't contravene the Waste Framework Directive, we use the Clear Material Management Plan. We produce a management plan for each area of concrete or soil disposition. It's prepared within the Waste Management Department at Bradwell and approved by a Clear qualified person. How do we demonstrate our material is suitable for reuse? Chemically, we produce risk assessments for the areas of disposition that show that material going into that area will pose no risk. Physically, we use end-use specific engineering reports. For backfilling voids, this may be, it must meet this standard, or you will see subsidence. For creating a piling mat, there'll be an engineering design report for the piling mat. Generally, on the engineering side, we stick to the Highways Agency specifications for crushing and compaction because they give us a high level of confidence. So, quantity and certainty. We've determined how much material we need on site by carrying out a mass balance equation. We know how big our voids are. We know how big, generally, our piling mats are going to be and our foundations are going to be. We've compared that to each of the programmes and seen how much concrete they're all going to produce. It leaves us with a huge deficiency of concrete. Last time I checked, we're short about 15,000 metre cubed of concrete for backfilling our voids. Project-specific requirements are generally based on design. They will say we need X metre cubed of concrete crushed to go in a basement. So, certainty. We've committed to the ONR, to our local council and to the EA that we are going to reuse material on site. We do this in our care and maintenance state entry definition document. We've told the ONR what our site will look like when we enter care and maintenance, that our cooling water pump house voids will have been completely backfilled and capped, that our turbine hall void will have been partially filled. There's no wriggling out of this. We've already told the ONR. So we now have to fill and cap our voids. That is one of our strongest lines of evidence. We have engineering specifications which tell us what material in those voids are going to look at. And we also have our environmental statements made under the Nuclear Reactors Environmental Impact Assessment for Decommissioning Regulations and the Town and Country Planning Act. That commits us to reusing as much material on site as we can. So as examples, this is the Turbine Hall prior to demolition in late 2010. As you can see, it was quite a busy little building and a lot of pipe work. And this is the void left behind after demolition. The voidage space is approximately 20,000 metre cubed. And as you can see, we've actually created a ramp out of crush from the building walls. And we've got a small layer of crush on the bottom as well. This is the cooling water pump house voids, 3 voids at 1,500 metre cubed each. We've made a commitment to the ONR that these will be completely filled and capped in under 4 years. So, how do we go about doing this? We use material management plans, as I said. The way we've structured our material management plans is we can accept concrete from anywhere on site as long as it meets the chemical risk assessment criteria. We then crush it and grade it to meet against the Highways Agency specification, purely so we don't see later subsidence. Project-specific requirements. The ILW storage facility required a piling mat. So we reused site-generated soil and concrete under a Clear Code of Practice. It's 5,200 metre cubed in total, and then we had to import material on top of that because we couldn't supply enough at the time. We had a generic risk assessment because all the material used was inert soil and inert concrete, and the requirement for the material was detailed in the engineering design. Sorry, only a bit of animation, I promise. The process we use. We identify material early. We use the project waste management plan process to pick out material that may be suitable. We then send our characterisation team in to determine if it definitely is suitable. We assess the characterisation results against the risk assessment thresholds. If he meets it, we update the project waste management plan with specific criteria for that material, and it's fed back into the project so that when they go about demolishing everything, they sort of segregate anything that could be suitable. The material is then transferred to the material reuse point, a big stockpile, and it represents a change of ownership. That material stops being the project and becomes plant, structures and waste management. This is where it completes radiological clearance. The stockpile area is segregated by material point of generation. So we don't particularly want material from boiler house demolition sharing space with circulator hall demolition in case there's a later problem identified. We stockpile until we have enough concrete for a crushing campaign. We do a pre-crushing check for non-compliant materials. We crush using a mobile treatment plant brought onto site for the operation with its permit in place. We do a post-crush check and then we emplace the material. The key point of the entire process is actually records management, which tracks all the way through from the initial characterisation and waste estimate to the radiological clearance and how much is in place. And that's all placed on the land quality file for permanent record. So the benefits we've seen today: using a clear-coded practice prevents material becoming a waste. It is always being handled as a material. So far we've seen a cost saving of £100,000 on a single project. That minimises the disposal cost, i.e. you're not paying for your waste management, and you're also minimising your purchasing requirement. We've taken over 360 shipments off the road, important to our local stakeholders and all the local communities. We've minimised our own carbon footprint, and we've done it all without having to vary our permit or apply for an exemption. So, considerations prior to your use. What we've found as we've gone along and learnt this, you need a significant amount of information in advance. We have one of the most advanced characterisation programmes in the fleet, and it does pay off. You need a large area of space for stockpiling and crushing. This is where Bradwell really struggles, because obviously one of 17 years in 4 years, we really have no space to carry this out. We are a compact site to start with, and the requirement for use and what material is going to go in needs to be identified from the very start. There's very little room for late manoeuvring from the projects or in the site. So, as a bit of a discussion area on what we could potentially do in future is we could act as a receiver site for clear material. However, due to local planning considerations, and again, our local stakeholders not wanting mass import of material, this is unlikely to happen. We can act as a donor site, so rather consigning non-hazardous material as a waste, we could consign it as a material to a construction project that wants it. We could look at our risk assessment again and try and increase what we can accept in our own voids. Given that we're now on such a reduced timescale, this probably isn't applicable to us. Lessons learned: we could potentially have taken better advantage of the clear code practice and those higher thresholds if we'd started using it earlier. Or the sites that follow Bradwell and follow Salford should be able to take better advantage of this. There are several buildings that could potentially have been reused on site that were actually consigned as waste for off-site recycling.
Thank you very much.